each question will have its own row. Okay, and then we come to the data view and start filling for each subject also by row. يعني كل patient أو كل subject أو كل participant أو anybody who filled the questionnaire has to have a one complete row. يبلش يعني هي رقم واحد نعطيه اليونيك اي دي تبعه، نعطيه مثلا واحد، نعطيه whatever number، ونبلش نعبي مثلا gender 1 or 2، نحط 1، السكول 1 2 3 4 او نكتبها كتابة هي 2، university مثلا 3، and we fill the questionnaire into the data sheet as, or we can actually do it via Excel. We enter the data into Excel as numeric data. We prefer to enter it as numeric data, ones and twos and threes, instead of writing up things, unless the variable forces you to write something. يعني parental jobs مثلا, father's job, mother's job. Sometimes you have to write the sentence like medical doctor, student, engineer. Sometimes you have to write them up, but it's going to be hard to analyze it. So we just look at it in the analysis and try to categorize it. Okay. So مثلا إذا الأب بيشتغل بالnursing، إذا الأب medical doctor، إذا الأب بيشتغل بالhospital, we can say all these jobs are healthcare settings. مثلا engineering, all types of engineering ممكن نحكي عنهم engineering. So we categorize, بسموه collapsing the variable. فالvariable, instead of having a variable with 20 or 30 options or labels, we try to collapse it into 2 or 3 or 4 subcategories depending on the data. But sometimes once you are done with entering the data and you start your initial analysis, you then can collapse or summarize some of the variables into 2 or 3 or 4 subcategories or labels. Okay. So we start with an empty sheet in SPSS and we try to do the data entry. Okay. Now sometimes there's a variable that somebody didn't fill his question, or somebody missed the question of age, for example, or somebody missed the question of university. Okay. So as you can see, the university here will be missing. It's going to have a dot. This dot is what's called by missing value for that subject, for that patient, for that participant, for that specific question. So for the university, this subject did not fill the question for the university. Okay. This is called missing data. Missing data, now you have to analyze and see that specific question. How are you going to handle this missing data? If we go back to the actual data set, if we do at the end of the questions, there's yes and no. For example, anxiety, yes and no. Worry, yes and no. Depression, yes and no. We're going to analyze these. So we go to analyze descriptive statistics, frequencies. We hit reset. Go all the way down and see these questions with yes and no. Anxiety, yes and no. Worry, yes and no. Depression, panic, loneliness. Let's pick some of these. And hit OK. Okay. So now the question has changed from the increase, did not change, and decrease into yes and no. So this table gives you the prevalence of self-reported anxiety among medical students in Jordan. So those who answered yes, they self-reported that they have anxiety, and the percent is 49.2%. 49.2%. We have worry, medical students who were worried about their situation before Jordan had the lockdown when schools were off, 72.4. Now note that this is self-reported. I did not ask them questions to diagnose anxiety or worry or depression. I asked them to self-report their situation. Depression, you have 23% prevalence of depression, 23%. Panic, you have 22% panic, okay? Now, let me just give you an example when we have missing data, what's going to happen. So let's go to the data set, highlight all these, and delete them. Okay, delete some of these values here, and do not save it. Just go to descriptive statistics, frequencies. Exact thing. Now what you will see is this table. We've deleted 45 cases. They are called system missing. We've told SPSS that those with the dots are considered system missing. They have missing values. Okay? So SPSS is going to do what? It's going to give you a percent. Let's give you a valid percent. The percent will include the missing cases. So the answer options now, no, yes increased, and you have missing. Okay? You have missing, so you have 48.9% of participants did not have any change in anxiety. Those who reported increased anxiety was 47.9, and you have, if you add these two, you have 96.8% of the sample. Now you have system missing 3.2%. So you have 3.2% missing cases. Now, normally, we do not report missing cases. We look at missing cases, evaluate them. If it's within 5-6%, you're good to go. Now your percentage for missing cases is 3.2%. Okay, their number is 45, so we have 45 cases, 3.2%. And we do not report these percentages. We actually report these percentages. So those who reported to have increased level of anxiety were almost half of the participants, 49.5%, and the total number is 1359. I'm not dealing with the whole sample anymore. I'm just dealing with 1359, which gives an indication that there are 45 cases missing. So this table should be reported as such. 49.5% of participants reported to have anxiety, and we have 43.2% or 45 cases missing. Okay, so when I report this table, I will report the yes, the no, the yes, and the total. And the total is 1359, and I'll give you an indication that the actual number is 1404. So you'll figure out that there are missing cases here, which is 45. To evaluate missing cases or missing values, we call them, we look and see if the missing are within 5% range. If they are within 5% range, that's fine. Now the problem is when you have the main variable that you are assessing is missing, and it's missing in a way that will affect your results. For example, if you are asking, if your whole survey was to assess smoking status among medical students, and females did not like this question, so they tend to skip it. So females will not report their smoking status. So the smoking status will be mainly reported for males. It will be missing for females. So the prevalence or the percent will be reduced because you are dealing with missing values. And these missing values should have been increased because those who decided not to answer that question were probably going to be answering that they are actually smokers. So you have to look into the missing value. Now, the value that's missing is not a value that you will know. It's a value you have to judge, and then you have to consider what to do with the data afterwards. Okay? Nobody can guess a question that was not answered. Nobody can assess your smoking status if you did not smoke, or if you did not answer that question. This judgment or this assessment will be based on experience working with the population or the sample you are dealing with. Okay? So missing values is not something that you will be able to go back and ask the question again, but you have to judge, or you have to consider what are your options to deal with these data, and you have to say, we have missing data. We believe that these missing could be due to the fact that participants who did not answer, who were missing, they actually have the outcome of interest, for example, smoking. So judging on missing data is going to give you a lot of problems. It's going to be hectic. That's why we try to avoid missing data. Now, avoiding missing data is through, or missing values is through online surveys. Online surveys, you have to answer all the questions. So with this question, anxiety, let's go back and undo it actually. We can go back and undo here. I didn't like it. So we actually did miss the data. This is one of the problems. It's undo doesn't work all the time. So these cases are now actually missing. Okay. So anxiety, worry, depression, and panic. Now we have to answer one question. Are these mental health issues more prevalent among males or more prevalent among females? So we have to do the analysis not for one variable. We have to create a table that has two variables, anxiety and gender. Okay, so we have to assess the relationship by two variables. How can we do that? We go to analyze descriptive statistics. Almost everything you're going to do is going to be in descriptive statistics. And cross tabs. So we do analyze descriptive statistics, cross tabs. Okay, click on cross tab. Now you'll have the list of variables that you have here in the data. You have the assigned variable to the rows and the assigned variable to the columns. Okay, now gender is not going to be an outcome variable. Most cases, the outcome variable will be at the top, will be the column one. So if we are assessing smoking status, for example, we are predicting smoking according to gender, according to age, according to specialty, according to parental smoking status. Smoking variable is going to be at the top. It's going to be at the column. So we have to have the outcome variable, the main variable, the variable that we are trying to predict or to study and assess the relationship of that variable with all other variables. It's going to be at the column. Now this is confusing. Sometimes it gets confusing which one to put at the top, which one to put as a row, which one as a column. Just do it and deal with it later on. So we wanted the question that says anxiety at the column. We wanted the question that has gender. This is gender. Okay. So I put anxiety yes and no as a column, and rows I put gender. So you hit OK. Remember, anxiety had missing cases, so this descriptive table, before doing the analysis, it tells you that out of the 1404, you only have 1359, which represent 96, 97% of the sample, and you have 3.2 missing cases out of the 1404. So you have valid cases that will go into this table, missing cases that will be excluded from the analysis. Okay. Now what does this mean? Let me do it again so I can see the screen better. Okay. This is the table we are interested in. So this table gives you the distribution of the study participants by two variables, gender and anxiety level. Okay, gender and anxiety level. So among females, we have 805 participants. We have 554 males. So this table represents, this row represents the total number of females, which we have 805. This row represents the total number of males, which is 554. Sorry, 554. Okay. Now among females, I'm only considering the 805. What's the prevalence of increased anxiety, or those who reported increased anxiety? Or what's the number of those who reported increased anxiety among females? It's 475. So out of the females, which are 805, 475 out of the 805 reported increased anxiety. Among males, 198 out of the 554 reported increased anxiety. So we can calculate percentages, and we can assess if the percentages are different, percentage of self-reported anxiety are different among males than females. Okay, so before we do that, this is the main structure of the table. This is the table that you will be needing to do your calculations. This is the table that you will be needing. Now we need to add percent. We need to add percent for females and percent for males. We need to assess or compare percentage of anxiety for females, percentage of anxiety for males. So the percent that needs to be added is percent for each row. So females represent a row, males represent a row, so we need to add for a percent for each row separately. So 1% where females are 100% and males are 100%. Can do that by doing analyze, descriptive, cross tab. Okay, we want to do cells. It can give you the observed variable, expected variables. It can give you the percentage by row, by column, and out of the total. We said we wanted the percentage by row because gender represents two rows. So we want among males and among females. Okay? Okay? So it gave you a new table. The count, which is 330, 475, and the total is 805. Females, among males, we have 554, 198 of them reported to have anxiety, and 350 reported not to have anxiety. This table with these four numbers is just the same as this table that we just did. What we added here is percentage. We added percentage for females and percentage for males. We wanted to compare the prevalence or the percentage or the proportion of anxiety between males and between females. So we have to take females by themselves, males by themselves, calculate the prevalence or the proportion or the percent of anxiety, and see if these differences are significant or not. Now, if we look at the females, which they are 100%, it's very important to have the females as 100% and the males as 100%, because you're comparing two subgroups. Each subgroup should be dependent on itself. So females, we have almost 60%, 59% of females reported to have anxiety. Males, you have 35.7%. 35.7% of males reported to have anxiety. Now, this is your sample. Your sample is 1359 participants. So your sample is 1359. So it's the 805 plus the 554, which gives you 1359. Among these 1359, the prevalence or the percent of anxiety among females is almost 60%. Prevalence of anxiety or proportion or percent among males is 35.7%. Okay. In your sample, in this sample, females have higher anxiety levels or self-reported anxiety levels compared to males. Females have higher level of anxiety compared to males. Okay? So this table gives you an indication that in your sample, females have higher anxiety than males. How about in the population? So my sample is from medical students. How about if I want to talk about all medical students in Jordan? I'm considering only 1359 medical students as my sample. How about if I want to talk about the whole population? Now remember, I do sampling to be able to collect data, do similar analysis like this, and my critical point is to do inferential statistics or draw conclusions to the population. I can draw conclusions to the population using statistics. So how can I do that? How can I say these differences are significant at the population level or not? Now, there is a difference at the sample level. 60%, almost 60% of females have anxiety compared to 35% of males. If I go back, analyze, descriptive statistics, close tab, I did the cells I want to do in statistics, I want to do chi-square. Okay, we'll do a chi-square, continue. Now it's the same table, it's going to give me what's called by the p-value. These are the p-values, okay? Now my sample size is large. I will use the first p-value, I will use the person chi-square, and I will use this p-value. Now if you remember, p-values are dependent on the type of table that you have. We go back up here. This table has two columns, column number 1, which is yes, column number 2, which is no, and two rows, which is females and males. Two columns and two rows, so it's called 2 by 2 table. I have 2 by 2, ignore the totals. I have 2 by 2, okay? This is 2 by 2 table. It have a degree of freedom. I can calculate the observed values. In statistics, can calculate the expected values, observed values, and then I can do the critical T or chi-square, and then I'll calculate the p-value. This you have all covered during the, I think, second year by stat. And for now, I'm only concerned with reading these tables. Reading this table, the p-value, and reading this table. So among females, the prevalence of anxiety is almost 60%. The prevalence among male is 35.7. These are the sample level. If I want to consider a conclusion at the population level, are anxiety levels different between males and females? Are these differences statistically significant or not? These differences is the difference between the 59% and the 35.7%. So the statistical question is, are there statistically significant differences between 59% and 35.7% at the population level? Are these differences real, the 59% and the 35.7%? Are these differences due to chance? Now, the differences that you observe in statistic could be due to two main things. Could be real differences, so there's a real difference in the proportion or the percentage or prevalence of depression between males and females, or it could be due to chance. Now, the p-value gives me the probability of observing these differences due to chance. Now, when you start your study, you assign a value which is called the alpha value, which is going to be almost the probability of observing differences by chance. I will give you 5% chances, probability of chance. I will assign a 5% alpha level of for chance. It's called probability of chance. So when you start your study, I'll say, okay, I'll give you the money to do the study. I want to make sure your chance level are less than 5%. So when I come back, present the result, I'll tell you the probability of observing these differences between 59 and 35 due to chance. So my chance is very low. It's almost 0%. Okay? My chances are very low. So the p-value, this is called the p-value. The p-value. So the probability of observing these differences, which is 59% and 35%, due to chance is very minimal. It's almost like 0%. Okay, so my observed differences are real, while my observed differences are not due to chance. Again, I'm not talking about the sample. I'm talking about drawing conclusions, inferential statistics to the population. Okay, so it looks that females have higher prevalence or proportion or percent of anxiety compared to males in the population. This difference between the proportion or the prevalence of anxiety among females and males was statistically significant. So there is a real difference between these two in terms of anxiety level. Remember, to come up with this conclusion, you have to have a table set with columns and rows like this. So anxiety is at the top because it's my outcome variable. Gender is an independent variable. It has to be in one of the in the row format. Numbers, you have to have prevalence or percentage, 100% for males, for females, 100% for females. Okay? So you are comparing females, the 805, to males, the 554. And then you look at the p-value. Now, to explain chi-square in a different way. Chi-square deals with numbers. So imagine you have four rooms. Room 1, 2, 3, and 4. Imagine that you have 4 rooms. You have 100 participants who will be needing. Let me do this myself. Imagine you have 4 rooms. These are 4 rooms. You have a total of 100 participants, and you want these 100 participants to go into these 4 rooms. Okay. Now each room will have 25 chairs, 25 seats. So it's logic that each room will have 25, 25, 5, 25. So at this stage, the 100 participants went into these rooms just by chance. Each room will have 25 participants. Okay. Now, chi-square assesses the distribution of these. This is the distribution within these rooms. So will the 100 participants go into these 4 rooms as 25s, or there are other variables that will affect that? The other variables is, in most cases, smoking and smoking is yes, no. So there's no relationship between smoking and gender. We're going to observe what's called by observed values, which is the 25s or 26 in each room, plus minus. Now, since there could be a relationship between these two variables, smoking and gender, and this distribution will not work as is. Now, what we expect is that all smoker males will go into this room, so we'll have here. All female smokers will go into this room. Okay? So going into the room, imagine yourself going inside this room. You will ask 2 questions. Is it males or females? And then is it smoker or non-smoker? These 2 variables will determine if you are going inside this room or not. So the distribution of 100 in these 4 rooms is dependent on smoking and gender. Smoking and gender. Dependent on these 2 variables, smoking and gender. And this is what we are observing here in the chi-square. So the distribution of participants within these 2 variables, anxiety and gender, was actually not due to chance. the disproportionate distribution within these was not due to chance. So the 50%, the 59% was actually statistically higher than the 35.7%, and the distribution of participants was dependent on these two things, having anxiety and then gender. That's why we saw that almost 2/3 of females went into this room where there were more higher anxiety levels, while less men or less males went into the anxiety room and went into the non-anxiety room. So the level of anxiety was higher among females. The prevalence of anxiety was higher among females than males. The prevalence of anxiety was significantly higher among females than among males, or we can say the prevalence of anxiety was significantly lower in males than females. These differences in the prevalence of anxiety were statistically significant. They were real. At the population level, we expect to see an anxiety level that's higher among females compared to males. On the other hand, these differences in the proportions were not due to chance. These differences were actually real. How did we do this? We calculated the difference between the observed values and the expected values to calculate a chi-square, a Pearson's chi-square. From the Pearson's chi-square, the calculated versus the tabulated, the one that we actually see in the table, the distribution of the actual numbers in the table, these numbers. This is called the tabulated, the ones actually in the table, this distribution of participants in the table, compared to the calculated. We calculated the observed one, the expected ones. We can calculate what's called by chi-square. All this was covered during the second year. Now this is an application. What's important here is that these four numbers, the distribution of participants within these four cells, was not due to chance. There was a relationship between gender and anxiety level. Females tend to have higher anxiety level compared to men, or females tend to have higher anxiety level compared to men within this population. Now within this sample, if I'm talking only about the 1355, then the females had higher level for sure. Now to say the same, not about the sample, but about the population, to draw a conclusion about the population, we have to look at the p-value. Again, p-value is the probability of chance. Probability of chance. Probability of observing these differences, which is the 59 and the 35. Probability of observing these differences due to chance. I'll give you a 5% chance. If you give me a results with a chance more than 5%, then we have a problem. So the probability of chance that we calculated, which is the p-value here, Pearson's chi-square, the p-value was really low, was almost 0%. So the probability of chance in these observed calculations or observed percentages is really low. Okay, so this is the chi-square distribution. This is the chi-square statistics. This is the p-value. And if we go back and say, so what is the research hypothesis that you wanted to test? What is the research hypothesis you wanted to assess using these calculations? Well, my research hypothesis and my null hypothesis. So if you remember, the null hypothesis is the hypothesis that says there's no difference. The percentage of anxiety among males here equals the percentage of anxiety among females. And the small difference that you see the numeric values, the difference between 59 and 35 is just because you are taking a sample, and by taking a sample you're not actually measuring the population, and the small difference that you see is just due to chance. This is the null hypothesis. So the null hypothesis says that anxiety level among males are equal to anxiety levels among females. The differences are not real, they're due to chance, they're not significant. Okay? Alternative hypothesis, or the research hypothesis. The research hypothesis is the hypothesis that we came up with. We wanted to assess anxiety level by gender, and we said females will have higher anxiety level compared to males. Female students will have higher anxiety level compared to males. So we started with the null hypothesis and with a research hypothesis. Now the research hypothesis will say that the 59 is higher than the 35, and the observed differences are real. They are not due to chance. There's a real difference here. And this difference is not due to chance. Okay? And this is the alternative hypothesis. How to test the alternative hypothesis, or how to test the null hypothesis? We go back to the p-value. We assess the p-value here, which is going to be that gives us the level of chance, or the probability of obtaining these differences, which is 59 compared to 35.7 due to chance, which is very minimal. So the probability of chance is very minimal. Again, this table, to understand when to conduct this table, it includes numbers. It does not have means. So this is the main table that we use to calculate the chi-square. It will have the numbers. So this is the number of female who reported not having anxiety, 330. 475 number of females who reported having anxiety. This is number of males who did not report having anxiety. This is number of males who reported having anxiety. This is 805, total number of females, 554, total number of males. Okay, so these are the numbers that we are using to calculate this chi-square value, which is, this is the chi-square value. This is the number, these are the numbers that we use to calculate the chi-square value, which will provide us with the p-value. Okay, so these are the numbers. This is the number that I need to calculate the chi-square. I don't need percentages because I can simply calculate percentages from this table. So from this table, 475, if I divide it by 805, it's going to give me the prevalence or the percent of anxiety among females. If I do the same, 198 divided by 554, this will give me the percent of anxiety among males. So this is going to be 59, and this is going to be, we said what? 35. This is going to be 59, this is going to be 35%. These are the two percentages. But the numbers I need to calculate the chi-square and to calculate the p-value are these numbers. I don't need the percentages. I need these actual numbers. Okay? If we go back and do close tab, cells, you can get the this is the observed numbers, you can get the expected numbers. You remember the chairs and the rooms, the 25s, you can get these numbers here. You can calculate by row, by column. Let's do it by column and see what's the difference here. Now, by column, it's going to give you, you have the same numbers. These are the 4 exact numbers that we've observed up there. The percentages are going to be different because the percentages may be for those with no anxiety. For those who reported to have anxiety, which is 673, you have 70% females and 30% males. So this table with this distribution, with these percentages, it's observing the percentage by columns. It's called percentage by column. So for those who reported anxiety, 70%, which is 673, 70% were females and 30% were males. What we are interested in actually is the prevalence of anxiety among females and the prevalence of anxiety among males. Okay? This doesn't give us this. Okay? So this is how we what else we have here? Okay, let me so we've done percentages by rows, percentages by columns. Let's do the whole thing in one shot and see what's going to happen. So note that the chi-square did not change. Whatever you do for the table, as long as these numbers are fixed, these four numbers are fixed, then everything's going to be fine. We don't care for the percentages. We use percentages for description. So to make things a little bit more complicated, I just want you guys to play with SPSS and see what options you have. This is when you tell SPSS, I want the percentages. See, it tells you here by gender, which is by row. This is the 100%. This percentage is by anxiety, which is by column. So this is the 100%. And this is the percentage out of the total. Out of the total is, you have four numbers, you divide each by the total number. If we go up here, just give me a second, let me remove the cells. So if you calculate the percent out of the rows, which is out of gender, you divide each of these, 330, divided by this total. 475 divided by this total. Each of these divided by the total for each gender. If you want to do it by column, then you divide the number, the same number, not by the gender, but by the anxiety level. No or yes. This is the number you're going to divide it by. So you divide 330 divided by 686. 475 divided by 673. So the 100% are going to be at the column level. If you want to do it by the total, you divide the 330 divided by the total, which is 1359. Okay? Each of these you divide it by the total and you call it the total. This is a complicated table. It gives you the percentage by gender for each row, the percentage by column for anxiety level, and by the total, which is calculating 330 divided by 1359. This is the percentage by total. So each of these, percent by total, which is here, going to add up to 100%. Okay? Let's do it for another variable. Let's see what we have, other variables we can. Cross tab. So instead of the gender, let's do it by university. Statistics, chi-square, square. So we assess the level of anxiety not by gender but by university level. So if we are doing the null hypothesis and the alternative hypothesis, the null hypothesis will say anxiety level are not going to be different by university, and the actual differences that I see is due to chance. The alternative hypothesis will say that anxiety level will be different by university. So each university will have a different anxiety level, and the observed differences are real. So the p-value is going to be less than 0.05, less than 5%. Now, if we look at these, we see that Al-Balqa University, the anxiety is 56%, Hashemite University 45%, Jordan University 46%, Just 52%, Mu'ta 50%, and Yarmouk University is 55.7%. So they all range between 45 and 55. Okay, if we go at the Pearson's chi-square and look here, you see that the probability of chance is really high. It's 15%. I gave you a 5% and you came back with 15%. So we do reject the alternative hypothesis and accept the null hypothesis. The p-value is really high. The probability of chance is really high. So these differences are due to chance. Differences in the percentages here are probably due to chance. Okay, they are not real. Look at the Al-Balqa University, they have 71 participants. So any change in these numbers will affect the percentages here because they have a very small total number, 71. So these differences in the prevalence or in the percent of self-reported anxiety level are very minimal, are probably due to chance. They are not real. These differences are not real, they're due to chance. Now, one thing you need to consider, when we talked about males and females, we were able to tell which percent of anxiety is higher. Is it among males or among females? Here, even if this was significant, you can only say that these percentage of anxiety are dependent on or not dependent on university and anxiety. The distribution of participants within these cells is not dependent on anxiety and university. Can't tell which one is higher. Let's look at one that could be significant. Let's look at the year. So I picked up, sorry, I didn't say what I picked up. So I did descriptive statistics, cross-tab, anxiety at the column, and I picked up the current year at medicine, which is year mid. Picked it up. Okay. So this gives you an indication of the relationship between anxiety level and medical year at medical school. So for those at the first year, the percent is 61 anxiety level. Second year, anxiety level is almost 50%, 48%. Third year is 49%. Fourth year is 49%. Fifth year, 52%. Sixth year is 49%. There's no trend. You see first year is higher, but the numbers are really low here. So this relationship was not statistically significant. There was no relationship between anxiety level, and year of study. Year of study is first year, second year, third year, fourth, and fifth, and sixth. How about if we do it by okay. So if we go at the bottom, there's the year mid one. If you right click on it, you click on it, right click, variable information, it gives you the two options. So this is dividing, this variable actually divides medical students into the first 3 years and the last 3 years. So it gives you basic and clinical years, basic years and clinical years. So I want to pick this. So this is what I picked in my rows, and this wasn't even significant. So basic medical education, they have 50% reported anxiety, and clinical years, they reported anxiety 47.5, okay? So this difference was not statistically significant. The value was more than 5%, it's like 20%. So anxiety was not dependent on medical year, first to sixth, was not dependent on basic medical education and clinical education. Now, the reason for this is this data set measures the anxiety, depression, all these variables during the first phase of lockdown for the COVID-19. So this was collected, I think, mid-March to late March, so beginning of April. Now, the lockdown, government lockdown happened after March 20th or 21st. Now, between March 15th, schools were off. So everybody was having anxiety, probably. Everybody was having stress. Now, stress and anxiety, depression, all these emotional changes did not depend on lockdown or on closing the school, the closure of the schools or medical schools or universities. Everybody was having these symptoms, regardless of being at first year, second year, medical, clinical, non-clinical years. So this was the main reason for observing these differences. Now, normally we see more stress and anxiety if we are measuring stress and anxiety in the medical school. We see more stress, for example, for first year. Okay, first year, second year, we can see more stress and anxiety. Sixth year when students are graduating. This is something expected, but here it's called a plateau where everybody at the medical school were having stress, anxiety, because it was an era of unknown expectation. Nobody knew what's going to happen or what's going to happen. So this is kind of an explanation for what was going on. Okay. Let's do anxiety. So if we look at this, anxiety wasn't significant by year, clinical versus non-clinical. Worry wasn't significant. Depression was significant, see? depression was actually significant. Now be careful, this is called self-reported. Self-reported are not clinical characteristics, they just help people perceive the situation. So medical students self-reported that they have depression in 23%. So if I look at this table, so out of the total, which is 1404, 325 reported that they having depression, which is 23%. Now, for the basic medical schools, basic years, almost 26%, 25.9% reported that they actually have depression, and clinical years reported to have depression in 19%. So what I see is difference between these two numbers. At the sample level, these differences are obvious because I calculated them. Now at the population level, this is when we come to the null hypothesis. Null hypothesis says that, listen, the 19%, which is the prevalence of depression in clinical years, equals to 25%, plus minus, which is the depression in clinical years, in basic medical years. And the observed difference between the 19 and 25 is not actually real, it's just due to, I picked up a sample, it was due to the error, it was due to any other reasons. But by all means, the 19% is almost equivalent to the 25%. This is the null hypothesis. Alternative hypothesis says that no, the 25% is greater than the 19%, and these differences are real. These differences are statistically significant. This is when we go and calculate the chi-square, calculate the p-value. The p-value here is 0.003. I gave you 5% and you came back with 0.003, so you have very low level of chance in observing these differences. So the chance is almost zero. So come back and conclude, no, there is a relationship between basic medical, medical year, basic versus clinical, and depression levels. So depression is dependent on distribution of participants within this table, dependent on depression level and medical year. So those with basic medical education will have more depression compared to those of the clinical years. Okay, this is the chi-square 8.9. I don't care for the value of the chi-square. I want the value of the p-value, probability of chance. Okay. The same for panic. So panic, first, second, and third year panic, 26%. Clinical years panic, 16%. So self-reported panic was significantly higher, 26%, among basic medical students compared to 16% among clinical years students. And this was statistically significant. This was statistically significant. Okay. Loneliness was also significant. Basic medical years had more loneliness than clinical years. Nervousness, basic medical students had higher level of nervousness compared to clinical, and this was statistically significant. Here's the p-value. Okay. Insomnia. Basic medical students had higher levels of insomnia compared to clinical, 14.8% versus 9%. This is the p-value. Okay, so this was the lecture today, which included the chi-square and application of the chi-square. Tomorrow we will talk more about the t-test, an application of the t-test. Now you guys have the data set. You can go and do the analysis yourself. I think it's best if you go back and redo the whole analysis, play with the data, see what variables are of interest to you. We can have a discussion. If you have any questions, if you did an analysis that you want to review with me, we can have at the end of the class a session where you can share your screen and ask questions, okay? But this is a good opportunity for you guys to learn some application of statistics. How do we actually apply statistical values, statistical methods using actual data that's collected on medical students? Okay? Any questions so far?
دكتور أنا عندي سؤال إذا سمحت.
تفضل.
في بالفاريبل فيو شو اسمه الميجر اللي هو بيكون اوردينال والسكيل والنومينال، شو هو هذا؟ بالفاريبل فيو.
Yeah.
في عندنا الميجر.
هاي آخر شيء. هلا شوف السكيل سامعني؟ the scale this is called the measure. The measure gives you an indication about the scale. The scale is the المسطرة that you measure the variable on. Okay? This is sometimes really critical when you are considering advanced analysis. Let's go and see the value gender. Gender, as we know it, is male female. It's a string. If we click here, it's a string male female. I didn't share, I'm not sharing my screen. Hold on. So I have gender in two ways. Gender is male, female, and gender is 1, 2. So if we go back, gender, as you see it at the first one, is a string variable, and it should be a nominal value. Okay, so nominal means the answer options for gender is male, female, okay, and there's no one, like males are not bigger than females, then there's no order in them. So however you look at them, there is no order in them, okay? And the same for gender 1 and 2, they should be both nominal, okay? So a scale that's nominal, it will measure the variable on on that scale using values that have no numeric order. You cannot order males and females, which is bigger, okay? الآن medical year, for example, medical year is 1st, 2nd, 3rd, 4th, 5th, and 6th. We know that the 6th year is greater than the 1st year. So medical students could be assigned a value, and the value is considered to be ordinal. It has an actual numeric value within it, okay? Just like education, primary education, secondary education, tertiary education. At times it doesn't have numbers, but we know that primary education is going to be the lowest, or no education is going to be the lowest. Primary is going to be number 2, number 3 is going to be secondary, and then you go on. So this is education. It has no numeric meaning, but it can be assigned numerically. It could be ordered, ascending order or descending order. Now the university, it should have a nominal value because Balqa University is not bigger than just university. It doesn't have that value, that numeric value in the data. It doesn't make sense to have one bigger than one. Now this is critical when we are assessing university or any of these variables that I discussed as the main outcome variable. So we want to look at each and every variable in the data compared to this value. If we go and check the scales that I've done, so here I've added the values of the positive emotions. حكينا عن anxiety, stress, worry, fear. هذول كلهم اسمهم negative emotions. If you have it, I gave you a 1. If you do not have it, I gave you a 0. And then I added the ones. So this came up with a scale. Now this scale was supposed to be looked at as scale. So a scale is when you have values that you can assess and measure using a scale. Now a scale هو معناته مسطرة. معناته المسطرة هاي الميجر هاي هي عبارة عن السكيل اللي بقيس عليه الفاريبل. فهاي السكيل المسطرة will be nominal, ordinal or scale. In nominal إذا المسطرة هاي it does not have numeric values. The ordinal, if the answer options or the categories of the variable they have any numeric values, they could be ordered. The scale اللي هو when you have a continuous variable you have to measure it on a scale. يعني زي الage هلا ممكن اسال how old are you واحد يعطيني 25 واحد يعطيني 25.5 واحد يعطيني 25.56 واحد يعطيني 25.56224. هلا the difference between any two the number of values between any two ages is infinite. That's why we go and measure it on what's called by a scale measure. Okay, so these are the three main things for the SPSS. Okay. أي سؤال ثاني؟ حد عنده أي سؤال شباب؟ طيب يعطيكم العافية شباب. We'll see you tomorrow same time إن شاء الله 11 o'clock. Okay. My best wishes with you guys. I want you all to go back and play with the data. Come up with new questions, new hypotheses. Try to analyze them. Okay.
دكتور بدي اسال سؤال والله.
آه.
هلا احنا لما وصلنا الملف منك وصلنا جاهز على الاس بي اس اس، بس احنا لما نعمل كويشنير على جوجل فورم ونجهزه فبنطلعه اكسل شيت، فهل بنعبي الاس بي اس اس مانيوالي ولا بنجيب الاكسل من داخل دايركت على الاس بي اس اس؟
هلا this is more data manipulation before doing the analysis, but you don't do anything manually. Because when you have the data on Excel, you can import it into SPSS. CSV, I think, format. So you can import the data from using SPSS. It will be able to read the data in SPSS, in Excel. But the problem is going to be that you have to go back and recode almost each and every variable. Okay? Because what you want is, because let me share with you. What you will be seeing is that so this variable is going to be the same. University, it's going to be the same. This variable, for example, is going to be the same. Now, these you may need to go back and recode because this question, for example, was how often do you want to use social media as a source of information for COVID? And it has to be assigned numeric values, because it's never, rarely, sometimes, or all the times, or most of the time. So these values were, you are going to go back and reassign them to numeric values. Okay, but they will be read as is from the Excel. Now the way it's being read from Excel is not, I think you need to download the data into Excel, CSV, I think, file CSV, download it, and then you can import it from SPSS and read it in SPSS. Okay?
تمام شكرا دكتور.
هلا يعطيكم العافية شباب، و see you tomorrow إن شاء الله.